All right. So, hi everyone. Today we are going to discuss about channel splicing. It's a recent proposal into the Lightning Network, which basically allows you to resize your current channels that you already have on your node. This has been proposed by the Core Lightning team. Dusty Damon is the core maintainer of this feature. There already has been an experimentation implement of it in Core Lightning. So yeah, today we are going to see what happens at the back end and how it affects the end user and what all things are included to implement this. So this one here is the pull. Yeah, yeah, yeah. All right. So this one's the official pull request, which would be merged into the Lightning spec once it is reviewed and at least two of the Lightning clients implemented. It's numbered 1160. Uh, as you can see, this particular PR make changes to uh, four to three files in general. I guess Bolt 2, Bolt 7, and Bolt 9. In Bolt 2, they have described the new messages that would be needed to make the interactive transaction and initiate the splicing. Uh, yeah, and the other two, and on Bolt 9, they define a new feature to enable splice, which is the 62 and 63. It's called option splice. So there's an official website hosted by Dusty. The URL is lightningsplice.com. It has all these sections if you want to learn about it in detail. We'll go through some of the sections today to understand what goes on behind splicing.
Where can we access this? Can you share the link?
Yeah, uh,
lightningspice.com.
yeah, it's called lightningsplice.com. Wait. Alright. So, yeah, this particular section explains what is splicing and what are the how it will affect the end user and the developers of various wallets which use Lightning into their interface. So as you can see, at its core, splicing is a simple concept. To, basically, it enables you to resize your current Lightning channel without changing the channel IDs and all of those things. So you can, if you, what happens is, it, in Lightning Network, imagine each channel as an hourglass with a limited amount of sand inside it. So once all the sand goes to the other side, there's no way you can transfer the money from node A to node B if all the channel balance is towards the node B. So that becomes a problem if you are running a routing node because uh, that would decrease your routing fees up when all the liquidity goes on to your peers. So that is why splicing is important. We can add balance, we can shrink balance from channel, or we can do cross splicing as well between two channels. So you can shrink a channel and you can expand another channel in a single transaction. So this is what it allows basically. But while implementing splicing, there were many additional benefits also that were not intuitive when this proposal came up. So we are going to discuss some of these additional benefits and see how it is implemented as well. All right. So if you guys have ever used a Bitcoin wallet with Lightning into their interface as well, it generally shows you two kinds of balance, your on-chain balance and your Lightning balance. Now, since we guys are already well versed with what these two things mean, what is your on-chain balance and what is your hot wallet Lightning balance. But for 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 a newcomer to for a newcomer, this becomes a bit confusing. So they don't generally understand what's lightning, what's your on-chain balance, what are the benefit of having an on-chain balance or a lightning balance. So with splicing in, each wallet can show you just a single balance. Uh, how that works is if you have a lightning channel with some lightning balance on your side, if you want to transfer uh, some amount of the balance on chain, you can just splice out. You can create a splice out transaction to send some of the channel balance to some on chain address. So that way you won't have there won't like on terms of the user in terms of the UX, you won't be able to distinguish between both the balances. So now each wallet could have a single balance which includes your Lightning and your on-chain and off-chain balances. This is what this particular section uh, explains. As you can read, splicing once implemented across the network is the secret sauce that makes one balanced wallet possible. So yeah, feel free to interrupt me as well while I explain if you guys have any doubt. Now, what are the backend liquidity improvements that would be there once splicing is implemented into the network? So what happens is if you are a routing node, you act as a mini bank and you have different channels with almost like uh, maybe hundreds of peers, right, in the network. So uh, imagine if uh, if there's a vendor whose whose service is very popular and is being used by many users across the network. So when many transactions occur through your node to the particular vendor, you would be quickly dried up with uh, all the liquidity that you have on your side. So that way, if you don't have any liquidity on your side, your route would not be viable for any of the other transaction, and then you would not be able to gather all the routing fees that you would be if you had the liquidity on your side. So the general solution of this particular problem is routing nodes keep opening and closing new channels whenever they think it's feasible based on the fee rate on the blockchain, on the Bitcoin blockchain. But with splicing in, what they can do is uh, they can rebalance they can basically shift balances through some of the not so much used channel to the channel which are being used in very high frequency in a particular single transaction. So with each splice transaction, you don't just splice a single channel. Uh, you can splice multiple channels at once. You can also add some inputs or outputs as per your convenience, if even if they are not related to your channel operation in any way. So all this happens in a particular single transaction. So that reduces your operational cost of the routing node. There's a video. If you guys go through the lectures which are done by Dusty. Uh, he explains it diagrammatically in those videos. Wait, yeah. So as you can see, there are these different lightning channels, and it basically uh, does all the splicing of it in a single Bitcoin transaction. And there are basically endless possibilities of what you can do with the splicing. So if you have some on-chain Bitcoin source, you can add some amount of it in one channel, some in other channel, and the remaining on some other on-chain destination. Uh, Cross-channel sizing as well. So all these diagrams help you to understand why splicing is very important for the Lightning network and how it would enhance your Lightning experience as well. So it basically at the back end it reduces the operational cost required to run a routing node. Uh, uh, so that would help routing nodes to manage liquidity and earn more routing fees as well. So yeah. Now this is the high level technical overview of splicing. As you can see, there was this particular lightning channel. This was the old funding transaction between A and B. Uh, Now these are the states that were created while you were running the Lightning channel. Now, when you want to splice this particular channel, you create a new funding transaction. So I'm assuming all of you already know that a Lightning channel is initiated with a two of two multi-signature transaction, right? So you spend that particular output into a new UTXO with new inputs and outputs as well. And that would be then your new funding transaction. As you can see, there was this old funding transaction that is used as an input inside this, and there's this other on-chain address of
Mhm.
zero point 0.5 that is also included inside this particular funding transaction. So you rebuild the commitment transaction, the latest state that you have inside your Lightning channel. Uh, and then when this new funding transaction is in has enough confirmation. Right now it is suggested to be six. So when it goes to six confirmation, your channel resumes again, and you can then use these new balances to advance your channel state as well. Yeah. So splicing is the process of moving a Lightning channel's funding UTXO into a new spliced UTXO. Uh, so yeah, that is what we have discussed right now.
Yeah,
Now,
I
what
had a
happens?
question. I
Yeah.
had a question. Right? If you
Yeah.
can scroll up a little bit to the diagram, all
Yeah.
right? So there's an old funding transaction, and then we have a new funding transaction. So
Yeah.
ideally, okay, fine. So the new funding transaction adds more funds, right? Because on top we can say
Yes.
TX from A. So it's not
Yes.
that we're just using the same commitment transaction, we are adding more funds to it, or the funding
Yeah.
transaction. Sorry.
Yes. So there's
Right.
this protocol for building a Bitcoin transaction in a trustless manner between two peers. It's called interactive transaction protocol. So each A and B can add any input or any output that they want, and based on it, a new funding transaction is created.
Right,
And
got it.
then it would be used, then that particular funding transaction would be used to advance the channel states once that is included into the blockchain. You can also there is also some messages to RBF this particular transaction as well. So imagine if you created a transaction but the fee rate was too low or it didn't go through the blockchain. So you can RBF it as well. We'll have a look at all the new messages that are introduced in from splicing as well. Yeah. So as you can see, the pending commitment transaction must be rebuilt for the new splice UTXO before the moving of the UTXO, as well as any child HTLC transaction. So the latest commitment transaction that you have would have to be rebuilt so that uh, you don't lose any state, and the channel balances are as per your latest lightning state. One unintended advantage of this is, imagine if there's a lightning channel with maybe like hundreds of channel states, right? So now it basically grows your database. In theory, currently your Lightning database has no upper bound in terms of memory. It can grow to any extent, and that is a disadvantage because first of all, it's dynamic. Second of all, it grows unboundedly. As you do new payments, it grows, and there is no upper bound of it. So it becomes uh, a bit tough to back up the database to restore your node if you lose all the payment information, so you would lose all your funds. So what you can do is, if you have many channel states, you can create a splice transaction for this. So that way, your database would remove all these particular channel states that were there in your old channel. So your database wouldn't grow unboundedly if you splice your most used channel regularly. It would keep a check on the size of your database as well. So it sort of solves that as well. So yeah, I hope you guys understood what I meant by that.
Yep.
All right. So now, while creating this new funding transaction, it's very important that there is no new channel state is created, or your channel is not in operation. You don't do any payment, because if that happens, your new funding transaction wouldn't accommodate the balances that were shifted from one end to another. So there's this new message included inside the Lightning spec. It's called STFU, which means something fundamental is underway. So what this does is it sends your node into quiescent mode. So then there would be no channel state advancement while you are while you are in quiescent mode. So yeah, this is
I
a
have
new
one
one.
question pertaining this, Aditya. I mean,
Yeah.
the commitment transaction
Hmm.
is something that happens on the mainnet, right? So our old funding transaction, our new funding transaction, and the transaction from A, all these three happen on the mainnet, all right? And this
Yeah.
beige block, which shows the channel balance on the left side, the beige block,
Yeah.
all of this is happening on layer two, all right? So like
This is yeah.
how does the new channel like how is the state transferred from the old channel to the new channel, right? Because the funding transactions are all on the main net. So how does our new
Yeah.
channel know the state of the previous channel?
So when this funding transaction goes, this basically keeps the balances as per the latest commitment transaction that is inside your old Lightning channel. So when this particular transaction gets mined, your layer two application would automatically delete all those states, and it would consider the balances as per this particular funding transaction. We would have a look at how this happens while reading the spec.
Okay, all right, thanks.
Yeah. So even if you had like 1,000 channel states in this particular your particular old channel, when this funding transaction goes through, your node could safely forget all those states, and it could start advancing the channel uh, on a clean slate. So that would limit your database growth as well. All right. So uh, yeah. So to uh, to do splicing, your node would have to go into the quiescent mode, and each channel sends a STFU message so that you don't advance your channel states while you're splicing. Now, afterwards, we begin the transaction negotiation using the interactive transaction protocol. So, interactive transaction protocol is a protocol which enable two nodes to build a, a on-chain a Bitcoin transaction in a trustless manner. This involves each side taking turns adding inputs and outputs one at a time. The existing channel funding UTXO is added as an input to this negotiated transaction. So yeah, obviously, if you're splicing this particular channel, the output, the two of two multisig output, which was your funding transaction before, has to be added as an input uh, into this new funding transaction, and you can add some other inputs as well, some input which is not even related to your channel operation. Imagine if I want to send some coins to an on-chain address, I could include that in this particular transaction, and it won't be an issue. So that is why it reduces the operational cost as well. So if you're doing a Bitcoin transaction, you can splice some channels into it as well. So that way it would be efficient for you to manage your liquidity. Once completed, both parties validate the final transaction, confirming the new balance is what was expected, and the correct amount of fees are being paid to miners. So as you can see, once the Bitcoin, this particular transaction is built, both parties validate the final transaction. So this addresses Faisal's question. So the new transaction has to be built according to the latest balances that were there into the old channel. So and the and the correct amount of fees are being paid to miners. Then they sign the transaction and pass the signature over to each other. Yeah. So once they validate that this final transaction uh, has the new balances which was expected as per the old latest transaction, they send the signature over using the Lightning Network, and then it gets published onto the blockchain. After broadcasting, each node waits for six confirmation before considering the splice valid. At this point, they are able to forget about the old channel state and move over to the new splice one. This results in quite a large amount of database savings as well. So yeah, if your database has grown uh, to a size where it is tough for you to back it up, you can just splice some of the most used channel uh, to reduce the size of it as well. Now, this section deals with how to implement splicing. Uh, this is for l- developers who will be working to implement splicing into LDK or LND or any other client. So you can read it up and see how Dusty suggests you to implement splicing for wallet. Uh, yeah, I guess this was it. Now let's move over to the pull request, the official spec, which would be merged once this gets uh, reviewed. Yeah, so this is the branch. It's inside T-Bash fork. If we go to Bolt 2, yeah, you can see there's this section called interactive transaction construction. Interactive transaction construction allows two peer to collaboratively build a transaction for broadcast. This protocol is the foundation for dual funded channels as well. Yeah. So this interactive transaction constructions would be used in dual funding as well as splicing. So uh, the protocol makes the following assumptions: the fee rate is known, the dust limit is known, the n lock time and n version is known. Uh, yeah. So as you can see, the particular uh, here A and B are two nodes which are willing to build a Bitcoin transaction. A sends a TX input, B sends TX complete, A sends another TX input, B sends TX complete. So as you can see, besides this section, it explains what is happening inside this diagram. A, the initiator contributes two inputs. As you can see, A sends TX add input two times and an output here, uh, and an output that they then remove. All right, where do they remove it? In the next diagram. B, the non-initiator contributes one input and an output, but waits until A adds a second input before contributing. So as you can see, this is the whole interaction here. TX add input, it says complete, add output complete, add input, and then B also adds an input here. Then A removes an output. So uh, yeah, this is how basically a transaction is built over a network, and this is trustless as well. Now, this particular protocol is used in channel splicing, which is also a section to be included in Bolt 2. There's a different section for channel splicing. Splicing is the term given for replacing the funding transaction with a new one. Uh, For simplicity, splicing takes place once a channel is quiescent. So quiescent means you won't be able to advance the channel state when your channel is in quiescent mode. Uh, Operation returns to normal once the splice transaction has been signed, while waiting for one of the splice transaction to confirm as well. So once you exchange the signature and your transaction is confirmed, your channel would be resumed, and you can then add HTLCs and do route payment, resume routing payments as well. The splice is finally terminated when both sides send splice log to indicate that one of the splice transaction reached adaptable depth. Yeah, so this is self-illustrative, I guess. So as you can see here, this particular node A sends splice init, B sends splice X. So B accepts that, yeah, we want to splice our channel. Then they interactively build the funding transaction again. So here A adds an input, B adds an input, then again A adds an input. Uh, Once B adds inputs and outputs, all the inputs and outputs that it wants inside the transaction, it sends a transaction complete. A again adds an output. B then sends transaction complete. Then A is also done with all the inputs and outputs, and then it sends transaction complete. So now both of them has exchanged the transaction complete message. Now they will exchange the signature. So as you can see, the commit signature, uh, and then they exchange the signature. So at this point, the transaction has been built, and now it could be sent to broadcast. Then the channel is resumed. You can do all the normal channel operations like adding HTLCs. So this particular is the flow of doing payment on the Lightning Network. Adds an HTLC. Uh, this particular node then revokes an old state. Yeah, these six messages are what a Lightning payment is. Seven, sorry. Now, if for some reason the transaction that you built to splice your channel hasn't gone through the Lightning through the blockchain because of low fee rate, you can create an RBF transaction as well. So these are the RBF messages. RBF stands for replace by fee. So you create a replacement transaction with a higher fee rate. Uh, Once the particular transaction goes to the blockchain with enough confirmation, uh, the nodes exchange the splice logged message, and that way the splicing operation is completed. Below this section, they have explained all the messages and all the parameters that would be included inside the Lightning message. So as you can see, this is the splice init message. It has the channel ID, the funding contribution, fee rate, lock time, the pub key, and the init TLVs. Uh, these are the rules that should be followed by the implement. So if some of you are interested in implementing splicing for a wallet, maybe LND, LDK, or I don't know what is the current state of it is on CLN. So if you guys want to take it up as a project, you will have to read each and every point from this spec and then code it. Otherwise, uh, it would not be interoperable. So that is why spec is very important in Lightning Network. So this describes the behavior of the sending node as well as the receiving node. As you can see, must not send splice init if the channel is not quiescent. So it should go into quiescent before sending splice init. Must not send splice init if it is not the quiescent initiator. So only the quiescence initiator is allowed to send splice init. So these are the minor details that should be taken care of while implementing splicing uh, into a wallet. This is the splice at message. So this means the your peer has accepted your request of splicing. and then its requirements. Then they describe the TX, add input, add output, and the transaction complete methods. So yeah, this is what basically happens when you're going to splice your channel in the near future through your wallet. If you guys want to go into more detail of uh, what are the what are some other advantages of it, you can go through Dusty's lectures on it. He has uploaded every lecture on his own website as well. So yeah, this is the website that you will be looking for. It's called lightningsplice.com. Currently it says LDK announces intention to implement splicing. So LDK has made a tweet to include splicing in, I guess, Q3 or Q4 next year. I'm not sure. Eclair begins to work on splicing with their first splice related PR. Um, Dusty is the official maintainer of a splicing spec. Splicing implementation is completed as an experimentation into core Lightning. Uh, First on-chain splice completed by Dusty Damon. So this might be a link to mempool.space, I guess. Oh, it's on Twitter. Right here it is. So as you can see, this is a multisig 2 of 2, which is the funding transaction of the channel that Dusty wanted to splice. This is additional address that he added as an input, and this one should be uh, I guess the new channel address, channel funding transaction, uh, initial splice created. All right. So yeah, if you guys have any doubts, any questions related to splicing, I'll try I'll try my best to answer those.
So, currently, no wallets support splicing, right?
Eclair has started. I don't know what's yeah, it's already merged. It's called rework data model for splice. Uh, I don't think so. Oh, so it was in January. So I'm not sure. I'll have to check, but Eclair might already have implemented splicing. Core Lightning has an experimentation splicing inside it. Let's search and see. Yeah, so they have these uh, RPCs to initiate splicing. Okay, so you will have to do it manually. You will have to run these commands manually.
On your
The
CLN node.
yeah, on your CLN node. Uh, hmm. And this is only allowed if you run your node with experimental splicing flag. Otherwise, all of those would not work. Yeah. Other than that, I'm not sure if any other wallet has implemented splicing. This could be your, like, if some of you are interested to get onboarded as a Lightning developer, you can take it up as a project, maybe create some proof of work and then apply for grants. You might get a grant to implement splicing into some other wallet like LND, LDK, or whatever you choose to. So yeah, if 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 you guys want to do that, I think you will have good chances of getting a grant. Any of you has any questions?
Yeah, and then none from mine. Thanks a lot for the session and thanks for explaining and taking us through splicing. No questions from mine.